Hello and welcome to Yourpedia. My name is Aman Sharma and I am your mentor for CSC at Yourpedia. So today we'll be discussing some interview questions that could be asked in your BHEL interview. And the subject that we have chosen for this video is algorithms and data structures. So first we will focus on algorithms in this video. So subject is algorithms. Now first of all you need to understand what are the basic topics that you need to cover in order to cover the algorithms from interview point of view. So first of all you need to understand all the basic algorithms there are, like all the quick sort, merge sort, insertion sort, bubble sort, your selection sort. After that your greedy algorithm such as Dijkstra's algorithm, your Prim's algorithm, then you have your Croxels. After that you have Bellman-Ford, and after like these are some algorithms from divide and conquer and related to sorting. These Dijkstra's, Prim's, Croxel or Bellman-Ford are of greedy techniques that we use in order to find the minimum spanning tree and shortest path from a single source. These are some of the algorithms. You also need to concentrate on dynamic programming algorithms. It is also very important because the problems that are not solved very efficiently by greedy algorithm, we move towards the dynamic programming for that. And dynamic programming is just a better version of divide and conquer. So these are the basic algorithms that you need to understand. Time complexity, for given code you need to find the time complexity. You need to understand what is big O, what is omega, and what is theta time complexities and what they denote. After that, sorting and searching algorithms, then greedy algorithms, dynamic programming and divide and conquer, as I have told you earlier. Now next is, these are some of the questions. Now first we will start from the basic level of questions and then we will move towards a much better type of questions that can be asked during the interview. Because the interview process, if you see it, what they will do, they will start from the basic questions and they will keep improving the level of the questions that they ask you. And when you keep on going answering the questions, they will see what is your level, what is the level of your understanding, and based on that your interview will go on. So they will basically start from the basic questions. After that they will just improve the complexity of the question. So simple questions: what is a multi-dimensional array? 2D arrays, 3D arrays, you need to understand how the elements of 2D array are stored in the memory. So 2D array is stored in row major order or column major order, and depending on that you can understand whether array will store like this is 1 2 3 4. So array will store 1 2 3 4 or 1 3 2 4 depending on whether you are using row major order or column major order in the 2D array. Then what is double linked list? So double linked list is nothing but you will have a previous and next node for every node. So this is double linked list. Similarly, you need to understand what is linked list, then circular linked list or doubly circular linked list. These are type of questions that they can ask. Now next is explain the working of Prim's algorithm, how it is different from Croxel's algorithm. Now Prim's and Croxel both are used to find the minimum cost spanning tree. When you use Prim's algorithm, the way you move towards completing your minimum spanning tree, the tree will be connected throughout the procedure. In Croxel there is no guarantee. At the end the tree will be there, but in the middle steps there can be some parts where the tree is not connected. So you will get spanning forest also in case of Croxel, but in case of Prim's you will not get spanning forest, you will just get the spanning tree. And it also works on the Dijkstra's algorithm. So it is kind of an application of Dijkstra's algorithm that we use to find the shortest path from a source. Next, dynamic programming problems. You need to understand these: Fibonacci series, longest common subsequence, 0-1 knapsack, matrix multiplication. These are basic dynamic problems, and you need to understand how they work when you apply a normal greedy approach, or better, how they turn out to be when you apply a normal divide and conquer with recurrence relation, and what will be the time complexity for that. And if you apply the like if you find the substructure in the problem that we used to find in the dynamic programming problems, then what is the time complexity? If you look at Fibonacci series, it is based on divide and conquer. So for n levels, like let's say this is 4, so you will have 4 here, 3 here, f of 2 here, f of 2 here, f of 1 here, f of 1 here, f of 0 here. So for f of 4 you have nearly 2 raised to power 4, 16 elements, because this will also go further. So in the case of worst case, when you have a full binary tree, you will have 2 raised to power n function calls. So if you have 2 raised to power n function call, the time complexity using simple divide and conquer for Fibonacci series will be 2 raised to power n. But if you use dynamic programming, we will see that when you call f of 4, you need f of 3 and f of 2. So when you call f of 3, you need f of 2. Now if this f of 2 is computed once, this f of 2 need not to be computed again. Similarly with f of 1, so there are repetitive problems which are also got, we have found a substructure, and we have some problems which are in repetition. So we will store those values and we will just use those values when we need them again. So by doing this, we just need f of 4, f of 3, f of 2, f of 1. So you just need n function calls to be computed, rest you will use again and again. So you will space complexity will be more for Fibonacci series if you use divide and conquer, dynamic programming, but the time complexity comes out to be order of n. So similarly for all these algorithms, you need to understand how normal divide and conquer works for this and how dynamic programming improves the time complexity for these. Now next is why 01 knapsack requires dynamic programming, whereas fractional knapsack can be done by greedy approach. Now the thing is, thing with fractional knapsack is that in fractional knapsack, let's say you have a 5 kg of some item A. Now you can take 2 kgs, 3 kgs or 4 kgs depending on the value, depending on the remaining capacity. But in 01 knapsack, you cannot divide the item into 2 parts. You have to take it or you have to leave it. So that is the problem why we require dynamic programming, because we cannot reduce it. Next is various sorting algorithms and their time complexity and their recurrence relation. So you need to understand what is the recurrence relation for merge sort. It works under divide and conquer. So what will be the recurrence relation? What will be the time complexity for that? For quick sort, what is the recurrence relation? In the worst case, in the best case, and what are the time complexities in the worst case, in the best case? So all the sorting algorithms you need to study. Next is let's say the question is what is build heap? So build heap is used when you are given an array, and in order to make that array into max heap or min heap, we require build heap. Next is difference between build heap and heapify. So build heap is making a heap from scratch, and when you have made a heap and you delete or insert some element, or you can say you apply decrease key or increase key. What is decrease key? You take a node, you increase its value, it's increase key, you decrease its value, it's decrease key. Now when you decrease the value of the key, what it will do? It will change the trajectory of your heap, because it let's say that you have 10 here, 4 here and 6 here. Now if this is a max heap, if you change it to 3, now this is not a max heap. So you need to apply some program in order to make it a max heap again. So that program is heapify. One more thing that you can tell, max heap requires order of n time. Heapify requires log n time for one operation. So these are some basic things that you need to understand, and they can ask in the interview. Divide and conquer, greedy and dynamic programming techniques you should know. After that, how divide and conquer and dynamic programming are related. So basic answer, divide and conquer. In divide and conquer, there are some function calls. If we can find some function calls which are repetiting and there is a substructure in it, we can store those values and use those values when the functions are called again. So then we will be reducing the number of function calls. So the time complexity decreases drastically in this case. Now next is explain a problem which can be solved better with dynamic programming. There are many problems which can be solved with better with dynamic programming instead of your greedy or any divide and conquer approach. So the program is 01 knapsack, longest common subsequence. After that we have matrix multiplication. These are some of the examples which can be better solved with dynamic programming. Why we prefer binary search over ternary search? Now in binary search you divide the array into 2 parts, in ternary search you divide the array into 3 parts. Now why we are using binary search? Because the time complexity for binary and ternary search will be same. Both have, now binary search have time complexity as log 2n, ternary search has log 3n. So log 2n and log 3n asymptotically equal. When they are asymptotically equal, why divide the array into 3 parts and increase the computation of it? Just use binary search. This is the reason we use binary search. So these are, now you should understand what is the difference between binary search, what is and ternary search. If you know the difference between binary search and ternary search, you will be able to explain the interviewer that why it is better than this. So these are the topics that you need to understand very clearly and very deeply, so that you could give out the best explanation that can be given for that answer. Next is, let's say, in what conditions Bellman-Ford algorithm is preferred over Dijkstra's. Now we know whenever there is a negative edge cycle, let's say this is -5, this is -2. If there is a negative edge cycle, a cycle whose weight is negative, then Dijkstra's will not be able to compute whether there is a negative cycle in it. What Bellman-Ford will do, first of all, Bellman-Ford we will run V times. If there are V nodes, we will run it V times. Now if after V times there is a negative edge cycle in it, Bellman-Ford will see that there is a negative cycle, and it will just say that we cannot give the shortest path because negative cycle is there. If there is no negative cycle, all are positive cycles, it will give output. Dijkstra's will not be able to differentiate between the graphs which have negative cycles or which don't have negative cycles. So this is the main problem with Dijkstra's, that it is not able to differentiate whether the graph has negative cycle or not. Bellman-Ford for negative cycle will not give an answer. It will just say that I will not be able to compute it because there is a negative cycle. But if there is no negative cycle, it will compute the answer. Explain the working of Floyd-Warshall algorithm. Now you can easily explain the working of Floyd-Warshall algorithm. The time complexity for Floyd-Warshall is order of V cube, and what it does, it finds the shortest path to all the elements from a, all pairs shortest path Floyd-Warshall applies. Now if you use Dijkstra's algorithm here, now Dijkstra's normally take E plus V log V. Now E plus V log V can be written as, let's say, E log V, order of E log V. Now E can be written as, in worst case, V square log V. Now now what Dijkstra's does is, it will take an element and it will find the shortest path to all the elements from that single source. In Floyd-Warshall, we want the shortest path from all the sources. So you have to apply Dijkstra's V times. So V cube log V will be the time complexity. So that is why we use Floyd-Warshall to find the single source shortest path from all the sources, or all pair shortest path. So this is why we use Floyd-Warshall, and then you need to understand what is the working of Floyd-Warshall algorithm. Next is explain merge sort. You can easily explain merge sort. What is the role of selecting a good pivot element in the quick sort? Now if you select a bad pivot element, the quick sort will give order of n square time complexity. If you select a good pivot element, the quick sort will give you time complexity of order of n log n. So this is the importance of selecting a good pivot element, which should divide the array in fractions of n, not in a constant values. So these are some questions that you can, these type of questions that you can expect in your interview. And the motive of this video was to help you to see what type of questions they can ask, and what are the different concepts, or what are the different topics that you need to cover in order to cover all the questions that they can ask in the interview. So I hope you like this video. So for more videos like this, just keep sharing these, and subscribe to our channel. Now next, if you have any doubts, you can just put it in the comments, and we will surely try to help you out. So keep studying and keep sharing. Thank you.